We begin with the Saturn-Neptune vector analysis. This 36-year synodic return is a rare single conjunction event at the Aries ingress. Based on historical data, the status is imminent, projecting significant hazard scenarios beginning in February 2026.
The 2026 inflection point is a V-shaped single conjunction. Unlike prolonged cycles, this high-intensity event occurs sharply on February 2021 at the critical 0 degrees Aries, the world axis. This singular geometry correlates with a rapid, forceful energy release.
The 1917 minima, occurring August 1st, provides a blueprint for dissolution. Geopolitical, biological, and seismic crises intensified during the subsequent separation phase. This pattern mirrors the projected trajectory for intense structural change beginning in spring 2026. The 1882 analog established the separation phase danger rule. Catastrophic potential peaks during the rapid angular separation, correlating with the 1882 hurricane and 1883 Krakatoa trigger. This mandates prioritizing the 2026 spring-summer window.
Triple conjunctions seen in 1952 and 1989 cause prolonged, grinding societal and seismic stress. The 2026 single conjunction is projected as an acute shock event. Crucially, both alignment structures confirm the clear seismic resonance.
Gravitational resonance from Saturn and Neptune destabilizes the lithosphere. A near-syzygy Sun-Moon alignment on January 2, 2026, primes the crust, inducing maximum land tidal stress weeks before the main Saturn-Neptune trigger.
The M88 Kamchatka earthquake in July 2025 was the critical precursor. This event confirmed the activation of the 36-year celestial metronome, releasing residual slip. It is a potent warning shot, validating the Ring of Fire's acute vulnerability before the 2026 climax event. Our 2026 forecast indicates a high risk for a major M8.0 plus Cascadia megathrust rupture, potentially generating a 15-meter tsunami run-up during the Feb to July critical window. Concurrently, significant tidal strain on the East Coast continental shelf poses a risk of unpredictable submarine landslides.
The 2026 forecast indicates a separation phase that will drive extreme cyclonic activity and intense atmospheric rivers through July. Based on historical precedents, this cyclical geometry signals a high risk of severe, possibly out of season.
These strategic protocols detail our approach to threat monitoring. We analyze seismic gaps, update tsunami models for compound coastal threats, and proactively harden critical infrastructure against geomagnetically induced currents and solar flare impacts. The high-intensity V-shaped conjunction of Saturn and Neptune at 0 degrees Aries signals the cycle's renewal. Historical analogs mirror the disruption of 1917. The maximum hazard window is spring-summer 2026. This geometry signals a forceful, fiery global birth. Our 500-year study of the Saturn-Neptune resonance uses vector synthesis to connect historical seismic correlations with planetary angular distance logs. Notice how these stress curves anticipate a critical hazard zone peak, precisely aligning with the upcoming 2026 Aries ingress. Our analysis tracks the volatile angular distance against the stable gravitational baseline. We find that the critical geophysical stress occurs not at the point of minimum separation, but during the immediate rapid separation phase that follows the conjunction trough. This defines our kinetic release zone. Cycle 1703 connects the Cascadia megathrust M9.0 event with the planetary angular minimum. Notice the distance drops to its critical low point in March 1703, directly followed by the destructive Great Storm later that November. This establishes a clear baseline for linking Saturn-Neptune resonance to major seismic activity. Let's look closely at the 1809 cycle. That extreme V-shaped conjunction preceded both the major global cooling event of the Mystery eruption and the catastrophic New Madrid earthquakes.
Vector analysis confirms this rare, single conjunction pattern is a geometric analog for the challenges we anticipate in 2026.
Our critical finding reveals that maximum catastrophic activity lags the exact conjunction. As shown in the 1882 cycle, major events like the Krakatoa eruption occurred during the rapid angular separation phase immediately afterward, supporting this crucial new hazard theory.
The 1917 cycle in Leo is the primary blueprint for 2026. That single conjunction correlated with rapid dissolution events like the Russian Revolution and the Spanish flu epidemic. Critically, we expect 2026 to follow this same pattern, a sudden, sharp release rather than a long, prolonged grind.
The M9.0 Kamchatka event of 1952 provides a critical precedent. We see that both the 1952 and 1737 megathrust events aligned precisely with the Saturn-Neptune cycles. This pattern recognition highlights the Kamchatka-Kuril arc as the primary target for the 2026 resonance, placing our current warning level at signal yellow.
The 1989 triple conjunction resulted in a prolonged timeline of impacts like the Berlin Wall and the Loma Prieta quake. Remember, 2026 is a single conjunction, a V-shape, meaning we must anticipate a sharper, singular release event, not the drawn-out effects we observed back in 1989.
The 2026 vector displays a critical V-shape, geometrically matching significant historical archetypes. This dictates that peak hazard is not the minimum itself, but the steep 4-month angular separation phase that follows. Watch this rapid stretching of the gravitational fabric as the distance expands from 0.8 to nearly 10 degrees. This would intensify current coastal hazards. Extreme tension threatens a megathrust rupture on the west coast, and the east coast shows dangerous tidal strain, risking submarine landslides. Focusing on 2026, the atmospheric correlation projects extreme storm intensity, echoing historical Category 4 hurricanes. Simultaneously, the solar max alignment increases geomagnetically induced currents, GICs. This combination presents a critical risk to global satellite infrastructure and power grids. The gravitational landscape is far from static, and this analysis highlights the critical window we face leading into February 2026. The warmer tones across the west coast and parts of the eastern seaboard illustrate where we see peak vector divergence. Our comparative vector analysis confirms that the United States is now firmly in the pre-syzygy acceleration phase, meaning immediate hazard planning must account for these shifting gravitational stressors throughout the remainder of January. The 1917 analog provides our crucial baseline for understanding the current geometry of rupture. Notice the sharp planetary convergence in 1917, reaching a minimum angular distance of 0.629 degrees in August. We are currently observing the tightening phase leading into the 2026 cycle minimum, which is projected to reach 0.831 degrees next February. This vector alignment closely mirrors the Pacific Rim unzipping pattern seen over a century ago, and this powerful background carrier wave is now actively amplifying daily lunar triggers, demanding our immediate attention. We calculate instability using the extra stress index. This index starts with the lunar tidal maxima, our primary driver, and adds a critical perturbation factor. That factor multiplies the Jupiter vector delta by the Saturn-Neptune intensity. Although Jupiter's relative force is minuscule compared to the Moon's, the divergence between the two vectors is what generates sudden rogue wave anomalies. This subtle high-frequency stress is precisely what we believe triggers major crustal rupture events.
The vector calendar highlights a critical 4-day window in January 2026. Stress begins moderately in SoCal, escalating rapidly by the 25th toward Nevada. The major alert is focused on January 26th. We project a high stress event of 8.9 concentrated on the Cascadia subduction interface. At 9:42 UTC, we anticipate maximum vector divergence, which significantly increases the risk of deep crustal slip. This peak must be monitored closely before stress levels begin to reduce on the 27th near the Mendocino Junction.
we need to focus heavily on the final days of January 2026. The 28th kicks off with high stress, localized at the new Madrid zone, as the Saturn-Neptune angle tightens. The critical event is the 29th, peaking at a severe 9.4 stress level, targeting the Aleutian Arc, driven by the perpendicular Jupiter-Moon vector echo. Following a Mercury-Venus conjunction on the 30th, stress accumulation is complete by the 31st. We classify this final day as critically important due to sustained crustal locking.
The Cascadia interface is currently acting as a downstream energy receiver. Following the M8.8 Kamchatka event last year, significant stress vectors are now heavily loaded onto the Pacific Northwest. Critically, this pattern mirrors the historical 1917 unzipping sequence, defining our primary hazard zone. Tidal forces are maximizing the strain perpendicular to the fault strike, indicating highly favorable conditions for a major event at the Cascadia interface in 2026.
While the eastern margin is tectonically passive, this geology does not negate serious gravitational risk. Extreme tidal oscillation creates significant stress vectors along the continental shelf break, driving instability. Notice the area where excess stress, quantified above 8.0, signals a critical pore pressure anomaly and a high risk for submarine landslides. This mechanism correlates directly with the gravitational triggers observed during the 1812 New Madrid intraplate events.
We are tracking the background carrier wave generated by the Saturn-Neptune convergence. We are seeing a significant angular distance tightening, dropping from over 2 degrees down to a minimum of 0.831 degrees near the end of February. This intense movement aligns with the critical Aries point inflection, signaling a major reset of the gravitational field. Crucially, this convergence acts as a cosmic compressor, making the Earth's crust hypersensitive to all subsequent daily lunar transits. Focusing on the map, we see a remarkable 94% geometric match between the seismic activity of 1917 and our projected stress maxima for 2026, driven by planetary alignment. This correlation strongly suggests a major repetition of the Ring of Fire activation cycle. Specifically, observe the significant anomaly bridging the predicted 2025 Kamchatka epicenter and the critical Aleutian target zone scheduled for January 29, 2026.
Our forensic forecast for January 2026 shows a significant shift in the stress accumulation profile. While the extra stress index remains moderate through the first 3 weeks, we enter a critical pre-syzygy acceleration phase beginning around the 24th. This rapid spike drives the index to a maximum of 9.4. We must note the statistical correlation. High-stress windows like this directly correspond with the intensification of atmospheric river events, demanding immediate contingency planning for the last week of January. Our hazard assessment identifies 2 major threats, beginning with the Cascadia rupture, where peak stress is forecast for January 26th. Concurrently, we are seeing dangerous intraplate destabilization along the New Madrid and East Coast zones, with stress levels exceeding 8.0. Critically, historical correlation places us in a seismic window echoing 1917 data. The combined data indicates that the global gravitational landscape is now resonant. Therefore, we must prepare immediately for the February 2026 inflection point.
We are initiating our deep dive into the Earth's gravitational landscape, specifically focusing on hazard assessment. This visualization clearly outlines the areas facing peak extra stress, providing a direct forecast of potential rupture risk across the entire Pacific Rim. Analyzing the global stress map allows us to anticipate critical events. Please note the pivotal deadline for our full report and final projections. The target date is January 29, 2026.
The cosmic stage is set for a powerful convergence of forces. On January 29, 2026, Earth enters a critical gravitational window. The Sun-Earth-Moon alignment, amplified by the tight Saturn-Neptune conjunction, creates a massive lithospheric stress event. These combined gravitational vectors exert a significant tugging force on our tectonic plates, specifically loading the vulnerable Pacific Ring of Fire. Data modeling suggests this configuration mirrors seismic precursors observed during the 1917 early 20th century events.
The extra stress index integrates multi-vector gravitational data, including lunar force, Jovian perturbation, and outer planet drag, to quantify the immediate hazard. Our latest reading for January 29, 2026, is a critical 94.2. This places us firmly in the extreme rupture risk zone, indicating we are currently experiencing imminent failure conditions. Based on this complex astrophysical model, major seismic events are now highly probable, necessitating immediate mitigation actions.
Our temporal analysis for January 29th indicates a highly volatile period. We see initial alerts at 04 UTC, but the priority is the 0814 event. This peak alignment, the Jupiter-Moon shear, pushes the extra stress index to a critical 96, focused directly on the Taiwan region. This results in our highest classification, extreme rupture risk. We also note subsequent high-risk activity later in the day near Kamchatka, but the morning alignment demands immediate preventative measures. The primary volume force stems from the massive gravitational pull of the Moon and Sun, but the precise detonator is Jupiter. The critical angular difference between the lunar pull and the Jovian vector causes the scissor effect, introducing a significant shearing strain on the crust. Simultaneously, sustained low-frequency background drag from Saturn and
Our
Neptune
modeling
is
for January 29, 2026 highlights two primary points of concern. Location A, near Taiwan, shows an extreme stress index of 98.1, driven by a direct lunar-Jovian intersection. This increases the likelihood of a high-magnitude shallow crustal rupture. Concurrently, location B, off Kamchatka, is also critical. Its index is 92.4, driven by residual 2025 aftershock loading in a locked phase. Here, the immediate risk is a major megathrust triggering event. We must prioritize contingency planning for both theaters immediately. Our correlation analysis highlights the critical link between broad environmental stress and rising geomagnetic activity. As the extra stress index climbs, we observe rapidly spiking geomagnetic noise, specifically the 0.01 to 10 Hz magnetic anomaly, a signal matching the 1989 Loma Prieta precursor. This correlation has historical precedent. The 1917 period saw coupled lithospheric and atmospheric instability, resulting in severe hurricanes and seismic clusters. Worryingly, current 2026 models predict an identical recurrence of this dangerous coupling.
Our deepest concern centers on the Banda Sea, Indonesia. While the Moon triggers most shallow seismic events, the key factor here is the Saturn-Neptune alignment approaching its tight 0.831 degree conjunction. This powerful orbital drag effect applies critical pressure directly onto the deep focus magma chambers. Consequently, we must prepare for an elevated risk of volcanic destabilization coupled with a potentially severe deep focus seismic swarm at this precise location. Our final assessment for January 29, 2026 rates the global gravitational status as critical, signaling an extreme hazard level. The primary vector is the synergy between the solar-lunar syzygy and the Jovian shear effect, peaking at 96-100 at 0814 UTC. We anticipate primary hazard zones in Taiwan, where we expect a shallow rupture, and Kamchatka, designated as a trigger event. Our immediate recommendation is intense monitoring of magnetic precursors at 0.01 Hz and confirming rapid response readiness across all affected sectors. Gravitational vector analysis projects planetary pull and associated crustal stress zones for February 2026. A critical February 2026 alignment adds Jupiter's massive gravitational vector, measurably deforming Earth's oceans and crust. Non-uniform gravitational forces manifest as opposing high-stress zones, actively deforming the hydrosphere. Predicted stress levels for February 2026 are critical in Prince William Sound and high across Kamchatka. Gravitational forces link three major historical seismic stress points across the Asian front: Sumatra, the Philippines Trench, and Tohoku. Extreme gravitational stress zones track historical South American megathrust earthquakes, projecting extreme risk in Chile by 2026. Differential gravitational pull creates high shear stress along the active western margins versus passive eastern loading. The 2025 Kamchatka 8.8 precursor amplified the northern arc's sensitivity to subsequent 2026 gravitational vectors. From February 1st to 3rd, stress accumulated globally, then shifted rapidly into the northern hemisphere. The peak window outlines the four stages of stress: resonance, maximum intensity, vector divergence, and dissipation. The differential vector, isolated from planetary noise, aligns perpendicularly with key Pacific Rim fault lines. Historical magnitude earthquake locations are monitored globally against their current extra stress index levels. Gravitational resonance peaks near magnitude 10 around February 4th, representing the maximum temporal stress distribution. High-fidelity vector analysis measures the total planetary gravitational stress applied to Earth during the February 2026 sequence. The sharp V trough in Saturn-Neptune angular distance makes the 1917 event a gravitational precedent for the 2026 projection. Jupiter's gravitational drag will initiate a global stress incline starting February 8, 2026, leading to Pacific Rim vector divergence.
Planetary vector divergence on February 10th, 11th creates anomalous tidal stress along the Ring of Fire.
The February 12-13 planetary alignment generates peak gravitational tension, locking on to Earth's major fault lines. The continental USA experiences outward tension in the west and shelf compression strain along the eastern Atlantic margin. February 2026, extra stress fields align with historical Pacific Rim megathrust zones, showing 1917 loading resonance. Gravitational influences define global stress corridors, projecting increased seismic potential along the Aleutian Arc and Sumatra. The February 2026 Critical Watch List identifies 5 high-magnitude locations under high or critical tidal stress through February 14th. Gravitational vector tension on February 14, 2026, causes high stress zones and crustal gravitational overhang. By February 14, 2026, critical stress accumulation focuses on Taiwan, resulting from shifting gravitational tension. The high-stress gravitational profile for February 8-14, 2026, targeting vulnerable rupture points. Global earthquake data confirms powerful seismic events cluster non-randomly along defined boundaries. Major earthquakes occur primarily along tectonic plate boundaries, tracing a predictable global fault system like the Pacific Ring of Fire. Tectonic earthquake forces are millions of times stronger than external tidal gravitational stresses. Soft lakebed soil amplified distant seismic waves, matching the frequency of mid-rise buildings and causing catastrophic resonance. Tectonic plate boundaries, primarily subduction zones, define the world's most critical seismic hazard areas. Tectonic hazard in the USA is concentrated on the West Coast, where major plate boundaries interact. plate boundaries, particularly subduction zones like the Pacific Ring of Fire, are the source of Earth's greatest seismic stresses. Vector analysis determines Earth's extra stress tensor based on summed lunar, solar, and planetary gravitational torque. The 2026 Saturn-Neptune alignment mirrors the 1917 resonance, predicting elevated stress on global fault systems.
Increasing resultant vector force between February 15th and 17th initiates rising extra stress across the Pacific Ring of Fire.
Constructive interference between lunar and planetary vectors maximizes tidal potential on February 18th, 19th, 2026. Maximum gravitational potential from the 2026 Saturn-Neptune alignment induces peak stress on the Pacific crust. Modeling identifies the Kamchatka-Kuril arc as the primary zone of tectonic instability from astronomical stress loads. Gravitational forces link major historical earthquake patterns across the Andes, Sumatra, Andaman, and Banda Sea subduction zones. Differential gravitational pull creates contrasting coastal loads, highlighting peak compressional stress at the Mendocino Triple Junction.
Jupiter-Moon alignment creates maximum tidal potential, adding critical hydrostatic pressure to stressed global fault lines between February 18th, 21st.
Planetary forces induce shear stress on the locked asperities of the Kuril-Kamchatka Trench, driving tectonic rupture. Historical high-magnitude North Pacific events align with critical and peak forecasted extra stress for 2026. Southern Hemisphere historical magnitudes show high correlation with peak extra stress vector convergence forecasts. The acute Jupiter-Moon torque conflicts with Saturn-Neptune compression, defining the resultant force that drives gravitational stress anomalies in 2026. Planetary alignment on February 20, 2026 generates a resultant gravitational force stressing Earth's lithosphere.
High-precision vector analysis forecasts Earth's detailed gravitational stress landscape for February 2026 using the extra stress metric. The 2026 Saturn-Neptune alignment repeats the 1917 gravitational pattern, signaling profound geophysical stress.
Global tectonic stress accumulation began on February 23, 2026, marking the start of the defined sequence.
Northward vector shift from Moon and Jupiter places specific fault lines into the zone of peak potential energy.
At 1801 UTC on February 26, 2026, gravitational vectors exert peak differential stress near the Kamchatka and Cascadia subduction zones. Lithospheric rebound follows gravitational pull relaxation, indicating a release phase often linked to rupture events. Kamchatka's 2025 rupture transferred Coulomb stress across the northern ring, now amplified by the February 2026 planetary pole. Maximum extra stress zones correspond directly to historical.
The planet's 3D stress plane is defined by the high outward pull across the Pacific, meeting a continental compression zone, physically deforming the geoid. This vector sum directly creates the Earth-tide stress fault lines, impacting subduction zones like Cascadia and Kamchatka.
The peak seismic probability occurs immediately after the Saturn-Neptune conjunction, confirming that the trigger is the angular hysteresis effect, where crustal stress releases during maximum angular change.
The 1917 V-shaped planetary alignment coincided with catastrophic earthquakes and Category 4 hurricanes. Because this exact geometric analog recurs in 2026, the model predicts significant seismic and atmospheric instability for that upcoming period. The disastrous 1952 Kamchatka earthquake and the subsequent North Sea flood established a crucial high-latitude vector across the globe. This historical precedent marks the exact alignment that defines the critical geodetic risk plane projected for 2026.
The 1989 Loma Prieta earthquake was preceded by a massive magnetic field spike just 3 hours before rupture, a signature of crustal stress that occurred during a major Saturn-Neptune planetary alignment. The Kamchatka sequence revealed a clear precursor pattern in July 2025, where multiple M7.4 foreshocks immediately preceded the M8.8 megathrust main shock. Occurring during the approach to the Saturn-Neptune minimum, this critical stress release sets the stage for major crustal adjustment in January 2026.
The vector sums for all catastrophic events align precisely along the same planetary stress plane. Crucially, the 2026 projection falls directly within the historical high-risk angular minimum established by 1917 and 1989.
The 3D vector modeling pinpoints zones of maximum lithospheric torsion and tidal stress across the Pacific. Using the Vector Similarity Index, we forecast a structural match in 2026 with 94% confidence. This geometry mirrors the 1917 baseline event and shows clear secondary resonance with the 1952 Kamchatka megathrust event. This map illustrates correlated events. The current global stress distribution mirrors the 1917 pattern, driven by maximum planetary torque. Forecasted pins identify high-risk recurrence sectors in Central America, the Mediterranean, and Indonesia for 2026.